Hello, we're looking at Module 4, Homework A, Tab 3, Part 1, Ratio of Speeds. So we are asked to calculate the ratio of the speeds lowercase v sub e and lowercase v sub p of an electron and a proton after they have been accelerated through the same potential difference in a parallel plate capacitor. The masses of the electron and protons are lowercase m sub e and lowercase m sub p respectively, and both have the same magnitude of charge but opposite signs. So when the charged particles are accelerated through a potential difference, capital V, they gain kinetic energy. The work done by the electric field in accelerating a particle from rest through a potential difference, capital V, is converted into the particle's kinetic energy. The electric potential energy, capital U, gained or lost by a particle with charge lowercase q when it moves through the potential difference uppercase V, is going to be uppercase U is equal to lowercase q times uppercase v. This potential energy is converted into kinetic energy as so. Ke is equal to q times capital V. So the kinetic energy of the particle after being accelerated through the potential difference is going to be Ke is equal to 1/2 times lowercase m times v squared, where m is the mass of the particle and v is the speed of the particle after acceleration. Since all the potential energy is converted into kinetic energy, we can get q times uppercase v is equal to 1/2 times mv squared. And if we're solving for v, the speed, we get v lowercase v. Should probably change these ever so slightly so that it's easier to tell what's upper and what's lowercase. This is going to be little v is equal to square root of 2 times q times uppercase v, all divided by little m. So both the electron and proton have the same magnitude and charge, which is q, that looks like a 9. Q equals E, where E is the elementary charge, and are accelerated through the same potential difference, capital V. The only difference is their masses. So for the electron, we have little v sub E is equal to the square root of 2 times E times capital V, all divided by m sub E. And for the proton, we have v sub p, this should be little v sub p is equal to the square root of 2 times E times capital V, all divided by m sub p. And now we have to calculate the ratio of v sub e over v sub p. So we can get lowercase v sub e, all divided by lowercase v sub p, is equal to square root of 2 times E times capital V all over m sub e. And then that's divided by the square root of 2 times E times capital V all over m sub p. And if we simplify this expression out, we're going to get v sub e all divided by v sub p is equal to the square root of m sub p all divided by m sub e. And that is going to be our final answer, which is the ratio of the speeds. This result shows that the electron moves much faster than the proton, as the electron has a much smaller mass compared to the proton. The speed ratio depends on the square root of the inverse of their mass ratio.